Hey guys, this video is an introduction to the Fourier series. And for the Fourier series, we can expand a function which has like a period from pi to pi to the form of this. So basically, if you have a graph over here, and the period is 2 pi, so you'll look like this. And if you copy, then you'll just look like continuously like this stuff. And Fourier series said this function can be represented or expanded to this form. We're going to take a look how can we derive this formula. So first we need to consider something which is cosine mx cosine nx dx. We first need to consider this integral, and from the formula of cosine x plus y, this is going to be equal to cosine x cosine y minus sine x sine y. And cosine x minus y is equal to cosine x cosine y plus sine x sine y. So combining these two terms, we can get that cosine y is going to be cosine x plus y and plus cosine x minus y divided by 2. And now, if we plug in, we can see this term is just equal to cosine m plus n x and minus cosine m minus n x and divided by 2 dx. And for from pi to negative pi of cosine n x dx, where n is equal to 1, 2, 3, and so on. This you can see this is equal to 0 because if you draw a graph, the area under this curve for like n equal to 1 is equal to 0, and for like n is equal to 2, this is also equal to 0. If you draw the graph like this, you can see it is equal to 0. So basically, if m is not equal to n, this term is just going to be equal to 0, since the area under the curve is going to be 0. And now if we consider as a case of m is equal to n, we have this integral to be cosine n x dx. And we know that cosine 2x is equal to cosine x minus sine x, and this is equal to 2 cosine x, and this one is minus 1. So cosine squared x is equal to cosine 2x plus 1 divided by 2. And take the integral 2x plus 1. And from the previous example, we can see this is going to be equal to 0 because the area is going to be 0. So this term is just basically equal to pi. And for the case of this cosine mx and sine nx dx, we're just using the formula of sine x plus y is equal to sine x y sine cosine y plus sine y x, and sine x minus y is equal to sine x cosine y minus sine s cosine y. And you can see this will be expanded out in the sine x plus y and this like sine x minus y in this kind of form. And you can see this term is just going to be equal to 0. And for the case of m is not equal to n, you can see that. And when m is equal to n, this is also going to be equal to 0, because cosine nx and sine nx is basically sine 2nx, and this divided by 2. If you take the integral, this is also equal to 0. So this integral is going to be equal to 0 for all integers of m and n. And now we're going to take a look at this from sine. Similarly, we can see that when m is not equal to n, this term is going to be 0, and when m is equal to n, this term is just going to be equal to pi. Now moving on, we're going to see how this formula works. So Fourier state is that, so basically if you time a constant over here, or another function, and to this side and to that side, blah blah blah, and times gx, and if you take the integral from negative pi to pi, and from negative pi to pi, they must be equal, they must be equal. So the goal over here is to using this identity to find the term of an and bn. Now, from the previous identity, the first one is that when m is not equal to n, this term is equal to 0, and m is equal to n, this term is equal to pi. And for this, it is just going to be 0, and from this is going to pi. So we can see that when we take the, for the an, we just take the integral of negative pi to pi dx, an2 negative pi dx, and plus the rest. And you can see that negative pi cosine nx is equal to 0 because the area under the curve is 0. And for this, it's also the same. So basically, if you do that, you can see that all the terms are 0. And now, so this term just basically equal to an times 2 pi, and divided by 2 is pi an. Thus, an is equal to 1 over pi times negative pi times pi and fx dx. And for the case of an, we can see that if we take we time both sides by fx cosine nx from negative pi to pi dx, and an2 cosine nx dx, this term is equal to 0, and then minus 1 an cosine for this case we just denote it as m, so we don't mess up something. So cosine mx times cosine nx and dx integral and plus blah blah blah. You can see from this identity, this term is just going to be equal to 0. And for m is not equal to n, this is also going to be 0. And for m is equal to n, this is just going to be like pi. And times an. And basically, so an is equal to 1 over pi divided by and times the integral of negative pi to pi of fx cosine nx dx, and similarly you can see bn is equal to 1 over pi times the integral of this fx sine nx dx, and a0 is equal to this. So now we basically prove the formula. Okay, moving on. If we have the period of from negative L to L, and we want to see how we can expand as a formula or the function to the form of the Fourier above over here, how can we like vary and make it like similar? So we want to like from the range of L to L, we want to get to negative pi and pi. So basically, if we time, like if we look at the inverse, we have nx divided by L pi, and when x is equal to L, this is just going to be this one is L, so this term is just going to be n pi, and when nx pi L is going to be, just substitute that n pi L x is equal to t, or no, this, substitute this. And now wait a second. And similarly, we can get, this is going to be, you substitute this dx from negative L to L and move that to that side, we can get L divided by pi and dt. And so now the formula is going to be, x, when x is equal to pi L as equal pi LT. Oh wait. This is pi divided by L. So now we can see that from this transformation we can get this to that dt. So from this we can get the formula to be an is equal to negative L or 1 divided by L, negative L to L of fx cosine n pi xl dx, and bn is equal to 1 divided by L of L fx sine n pi xl dx, and an is equal to blah blah blah. Kind of forgot. Okay, let me see how to simplify this. Oh, if we like xl is equal to nt, or this xl pi is equal to t, so we can see this formula is just going to be like from negative pi to pi of fx and times cosine, and this is going to be equal to t nt and dt, and where dt is equal to pi L dx. So dx is going to be L divided by pi, L divided by pi. So now these two terms cancel each other out. So this basically leaves the form of fx cosine nt dt, and we can rewrite it to like form to this equation. So basically, which matches the equation written above. So this basically proves the formula to be like this. Okay, we're done.